What's going on, students? Hope you're all alright. Welcome to the fourth installment of our chemistry GCSE series, where we're going to be looking at the electronic structure of atoms. So what do we mean by the electronic structure of atoms or the electronic configuration? Well, if you remember from the previous videos, all atoms of elements are made up of three subatomic particles: protons, neutrons, and electrons. What we're interested in this video is how the electrons in an atom are arranged. And why we're interested in that is because the arrangement of electrons determines how that atom will react. And as you know, chemistry, a huge part of it is all about chemical reactions. So what we need to be aware of, firstly, is that electrons exist outside the nucleus in these things called shells or energy levels. Right? You need to understand that the first shell can only hold 2 electrons, the second shell can only hold 8, the third shell can hold a maximum of 8, and the fourth shell can hold a maximum of 2. Technically, this isn't correct once you get to A-level chemistry, but for GCSE, this is like gospel. You just have to accept this, okay? So if we look here, we have a random atom. Altogether, it's got 10 electrons, right? So the first 2 have to go into the first shell because that's just the way it fills up, and the remaining 8 are in the second shell, and the second shell is what we say it's full now, okay? Because you can't add any more electrons into it. So it says here, electrons fill up the shells closest to the nucleus first. We call those innermost shells the lowest energy levels, right? If you look at the atom on the bottom of the sheet, we have how many electrons here? 2, 4, 6. We have 8 electrons here, right? So 2 fill up the first shell, and the remaining 6 have to fill up the outer shell, right? This is an example of an atom with an incomplete outer shell, and this is something that's very, very common in chemistry. So, as we mentioned earlier, electronic structure determines how an atom will react. We say atoms are stable when they have a full outer shell, sometimes referred to as a valence shell. And it's just like a universal law that all atoms want to eventually become stable, right? So different atoms exchange electrons between themselves to attain full outer shells. And this is what a chemical reaction really is. It's just a transfer of electrons. So the atoms of some elements, known as the noble gases in group 0, something like neon you can see here, they all have full outer shells already. Therefore, they don't react with other atoms, right? He doesn't need to gain or lose any electrons to have a full outer shell because he already has it. We call these noble gases because, of course, nobility does not mix with the common rabble. So here we can see neon gas. It's got a full outer shell. It's not going to react with anything. But if we look at oxygen here, it's got 6 electrons on the outer shell, right? So this guy needs to react with something to attain a full outer shell. It needs to either gain 2 electrons and fill up the outer shell, or it needs to lose those 6 electrons and go to the previous shell, which will then be full, of course, right? Okay, so how can we represent the electronic structure, the electronic configuration? Well, firstly, we need to know how to draw these diagrams called dot and cross diagrams, which is very similar to what we have here. And we also need to be able to write the electronic structure using numbers. So let's have a look at this. How can we draw this? How can we write this out? Well, it's got a very standard methodology, right? Find how many electrons of an atom the element has using the periodic table. The number of electrons in an atom is the same as the proton number. Okay, so here we have fluorine, right? It's got a proton number of 9. That means it's got 9 electrons. You simply add 2 to the first shell, and then you add a maximum of 8 into the second shell, and then if you go over that, you go into the third shell, and so on and so forth, right? So here it's pretty straightforward. We draw the nucleus, draw the first shell, put the 2 electrons in, draw the second shell, and add in the remaining 7 electrons. As you can see here, we like to pair up the electrons where we can. It just makes it look better, and that's really how we can draw that stuff out, right? And let's have a look. So yeah, the electronic configuration we would write out as 2, 7, right? 2 electrons in the first shell, 7 in the next one. Now, if we look at phosphorus here, it's got 15 as its proton number. Therefore, the electronic configuration will be 285. We can fit 2 electrons in the first one, a maximum of 8 in the second one, and therefore the third shell, the outermost shell, is an incomplete shell with 5 electrons in it. Okay, if you look here, the way we represent the diagram will be just like this. You don't always need to draw the entire structure, every single shell. More often than not, you can just draw the outer shell. with the nucleus in it, and people will know what you're talking about. Because like we said, reactivity is determined by the electrons in the outer shell. And that's really it. Please subscribe, comment and like, share the video if you think it will help people, and we've got way more stuff coming out. I'd really appreciate the shares. Thank you very much. Bye bye.